In this tutorial, we are going to talk about cyclicity. Cyclicity is a property of number by which last digit of numbers repeat themselves when they are raised to certain powers. For example, 2 to the power 1 is 2, 2 square is 4, 2 cube is 8 and 2 to the power 4 is 16, the last digit of which is 6. So we see that 2, 4, 8 and 6 are the last digits when 2 is raised to power 1, 2, 3 and 4 respectively. But when we raise 2 to the power of 5, 2 to the power 5 is 32. We see that the first number which appeared in 2 to the power 1, it has started to recur itself. 2 to the power 6 is 64. Last digit of 64 is 4. So again 4 has appeared which had appeared in 2 square. So we see that 2, 4, 8, 6 cycle will get repeated. Doesn't matter for whatever power we raise 2 to. By virtue of this property of number, we are able to find out last digit of given expressions of any given number. For example, if I have to find out, let's say, the last digit of 2 to the power 875 or 372 to the power 6481, we can find it out. Because last digit depends upon last digit of the base. And last digit of the base, whichever power it is raised to, the last digit always keeps on repeating itself after a certain number of power. So in this case, in the example of 2 that I gave, we'll say that cyclicity of 2 is 4. Because after every fourth power, the last digits are repeating themselves. And repeating themselves in the same order 2, 4, 8 and 6. So if you have to find out 2 to the power 873, let's say. We know that cyclicity of 2 is 4. 873 will divide by 4. And we'll look for the remainder. 873 when divided by 4 leaves a remainder of 1. We'll look at what is the last digit of 2 to the power 1. 2 to the power 1 is 2. So we'll say 2 to the power 873 will end with the digit 2. It's going to be a very long number, but we are not concerned with the number itself. We are only concerned with the last digit. And the last digit is going to be 2 because 873 by 4 is the cyclicity of 2, leaves a remainder 1. And if it leaves a remainder 1, we'll look at 2 to the power 1's last digit, which is 2 itself. So every single digit number follows cyclicity of a particular order. For example, cyclicity of 2, 3, 7 and 8 is 4. Similarly, cyclicity of 0, 1, 5 and 6 is 1. Any number ending with any of these digits, 0, 1, 5 or 6, does not matter by whatever power you raise these numbers, they will always end with 0, 1, 5 and 6 respectively. Cyclicity of the remaining digits, which are 4 and 9, are 2. Every even power of 4 will end with 6. Every odd power of 4 will end with 4 itself. For example, 4 to the power 1 is 4, 4 to the power 2 is 16, last digit is 6, 4 cube is 64 and so on. Similarly, every odd power of 9 will end with 9 and every even power of 9 will end with 1. So when we know these rules, it becomes much easier for us to find out what is the last digit of any given number when it is raised to higher powers. In our next tutorial, we will solve few questions based on cyclicity and see how cyclicity helps us in solving some of the seemingly difficult questions.